Good morning, everyone. Myself Lokesh Kumawat. Today I am present my topic nuclear reactor, neutron source and power generation for the course of PHN 631. Okay. So first we start from the outlines. What is the nuclear reactor and the working principle of nuclear reactor, uses of nuclear reactor, what is nuclear energy, nuclear power plant, and then working mechanism of nuclear power plant and then India's nuclear energy, and then finally conclusion. Okay, so okay, so first start with nuclear reactor. So what is nuclear reactor? The a device in which nuclear chain reaction are initiated, controlled, and sustained at a steady rate. So controlled at fission, nuclear chain reaction, or nuclear fusion reaction. Okay, so nuclear reactor are used to nuclear power plant for electricity generation. When the nuclear reactor have the many parts of the we discuss about the principal parts. These are the listed below: the core and moderate and control rods and coolant and fuel and radiation sheets. Okay, so next we talk about what is nuclear energy. So the nuclear energy is the nuclear in the nucleus or core of an atom. Atoms are tiny units that make up all matter in the universe. So the energy that holds in neutrons and protons like two, and then we see the two ways of obtaining energy are nuclear fission and nuclear fusion. Okay, so we see in the nuclear fusion. So the one neutron is bombarded on uranium-235, and then we get the barium 141 and the krypton 92, and we have three more neutrons, and then we have more energy. So we bombard one neutron on the uranium 235 and we get the 3 multiply of neutrons. So in the neutron fusion, this is the more neutron generation. Okay, so next neutron fission is the diagram of the heavy nuclei split into two smaller parts in order to become more stable. So we see the one neutron is emit three neutron, and then that three neutrons emit more three neutrons. So this chain is very become, so this chain is very large, and we have more and more neutrons, and them neutrons are faster neutrons. Okay, now we see the second way of energy generation is nuclear fusion. So in the nuclear fusion, light nuclei fuse together to form a heavy nuclei. So we have deuterium and tritium, and they combine in the metastable state, and then the helium atom is released, and the one neutron are released in this fusion process. So we see the fusion in is one neutron is emit three three neutrons, and the fusion is only one neutrons. So um, now we see the components of nuclear reactor. So we have three components of nuclear reactor. First one is fuel element. So in the fuel element we have the thousand of thousand of nuclear rods first in the reactor core. So mm, in the rods we have uranium 235 and 238 for reacting with the neutron. Okay, so this is the flexible nuclei. Okay, uranium 235 and uranium 238. So now we see the second component of nuclear reactor is moderator. So we see in the reactor core the neutrons are very fast, so they are less reactive. So we want to decrease their velocity, we use the moderator. The moderator wants to stabilize that neutrons. So what they work, they they work the mm, approx 0.04 electron volt neutron is bombarded on uranium 235, and the neutron, three neutrons generated approx 1 mega electron volt. So they, we see in the animation, the neutrons are further three or more, three neutrons, and the we see in the reaction the more three neutrons are generated. So we use the moderator like heavy water. So the heavy water contact with neutrons and they resist the neutron velocity. So the moderator works like this. So now we see the components. Third component of nuclear reactor is control rods. So this is made by boron and cadmium. So when we put rods in the core, then the rods absorb the neutrons, and then we remove the rods, and we see the rate of nuclear reaction will be increased. So, so we see the working principle of nuclear reactor. So in the nuclear reactor, we want to shield this core from the wall. So we use the concrete. Then concrete wall is totally shield the core and the reactor core and pump connected with the heat exchanger. So the reactor core and from the pump, the reactor core heat gives give in the heat exchanger, and heat exchanger will the mm, heat exchanger are rotate the turbine, and the turbine give the electricity. So we use in the power generation, for the power generation. So now we see the uses of nuclear reactor. So we know the nuclear reactor are all over the world, and we know the main use of nuclear reactor in the power generation in the nuclear power plant. So we next see the propulsion in vehicles and submarines or naval vessels for the production of useful isotope or neutrons, and we see the use of research and training. So in the nuclear power plant, we use the nuclear reactor, and mm, the nuclear power plant is the main use of nuclear reactor, and the nuclear power plant is focused on totally electric generation. Okay, so in the simple manner, we can see that very large machine that produce nuclear energy is nuclear power plant. Okay, so next, we see how does a nuclear power plant works. So, a nuclear power plant works in a similar way as the thermal power plant. The difference between the two is the fuel used to heat the water in the boiler, steam generation, and inside a nuclear power station, energy is released by nuclear fission in the core of the reactor. And 1 kg of uranium 235 can produce as much energy as the bringing of 4,500 tons of high grade variety of coal or 200 ton of oil. So we see India's nuclear energy. So we know the nuclear reactor, uh, from the nuclear reactor, the nuclear power plant is very useful for the Indian nuclear energy. This is the fourth largest source of electricity in the India, after coal, oil, and solid biomass. So we see recent days the crisis of coal. Then we use then the usage of nuclear energy from the nuclear power plant are increased in the India. So as of 2013, India has seven nuclear power plants with 21 nuclear reactors having an installed capacity of 5,780 megawatt. Okay, so we see then nuclear power plants in the India. We see the Pokhran and Rajasthan Atomic Power Plant and many other nuclear power plant stabilized in the India. Okay, so we see the advantage of nuclear power plant is the low greenhouse gas emission. So we see from the nuclear power plant this emit very less pollution in the environment from this, and we see the powerful and efficient. So we see in the that this is the very high reason, and from this electricity is very high range and very powerful, and this is the reliable and cheap electricity and low fuel cost. So we have only fuel cost is the roads, and they are normally easily take from the market, and they are low cost. Okay. So we see the disadvantages of the nuclear reactor is first is radioactive waste. So we see the radioactive from the nuclear power plant is like garbage, and that garbage is effect on human body, and then they have many type illness from in his body. So the next one is nuclear accidents, and they the all setup are very high cost. So next one is major impact on human body. So we see previously the disaster in the India is in December 1991. A serious radioactive leakage had occurred at Cyrus A research reactor of the Bhabha Atomic Research Center on the outskirts of Bombay, barely 3 kilometers from the heavily populated suburb of Chamber. Okay, so now we see the conclusion. So, nuclear power plants are also capable of producing huge quantities of nuclear electricity. So, the further reducing the need of addition coal or gas power plants, since nuclear plants can produce so much energy. Four fewer are needed in order to meet demands than are coal or gas plants. So our Prime Minister tried to increase the nuclear power plants in the India. Okay, thank you.